Greetings and welcome, friends. We've been proving triangles congruent using side. And it's page 266. I'm just going to look at a handful of problems here. I think it's actually a proper handful today as well. And it says this: decide whether enough information is given to prove that the triangles are congruent using side. Explain. So could I prove triangle PQS is congruent to RQS? Let's see, I've got one pair of sides right there. I could, by reflexive property, get that one. But no, I don't have any way of proving these two are congruent. So no go. I only have SS and blank. No third pair of sides. Question, comment, observation?
You couldn't say PR is congruent to RP.
You could, but that wouldn't be regarding the two half triangles that I was trying to work with. Yeah. If I knew midpoint, if I had something else.
It said like S is a segment, Y segment.
Yeah, right. Perfect. Something. But no, not enough. Let's see. Here we go. Here's question 6. Decide whether enough information is given to prove the triangles are congruent using the HL congruence theorem. Explain. All right, so I've got a, Now HL, what does the H stand for? Hypotenuse, and the L is leg. Now right now I do have right triangles, okay? Or I do have perpendicular lines. I could then say that these are right angles by definition of perpendicular lines, and then these are right triangles by definition of right triangles. I know, it's a lot of steps, but here we go. But the question is, do I have hypotenuse, friends? No, I've got leg. These aren't hypotenuses. But, behold, I could prove these triangles are congruent. I actually have no idea what the book says on this, but this is what my justification, kind of. Nah, I'm guessing the answer is still probably no in their book. But notice this, side, angle, side. By side, angle, side, I could prove the triangles are congruent. Okay? All right, I'll actually write it out. Triangle PQT congruent to triangle SRT. Reason, side, angle, side. So kind of no, all right? However, once I knew that, I could then have said PQ is congruent to SR by corresponding parts of congruent triangles are congruent. All right? But then it would be like unnecessarily redundant to be like, oh, but then the triangles are congruent again because of hypotenuse leg. So, kind of. I can prove congruence, but not directly using that theorem, so I think the answer is no. But I haven't actually checked what the book was shooting for on this one. But I just wanted to point out the triangles are congruent, just that's not how we would have proved it. And then when we proved it that way, we would have been too late, right? Someone else stole the credit. Side, angle, side. What was it in Fairly Odd Parents? He'd go, Dingleberg, like when Timmy's dad would yell about his name. I don't know.
Dingle. It's Dingle.
Dinkle? All right, I don't know.
The golden lump or something. Golden toilet seat.
Okay, yeah. Anyways, Fairly Odd Parents. Wow. Thank you for that was your Fairly Odd Parents episode recap. What's the name of Timmy's dad, or is he just known as Dad? He's just Dad character?
I thought it was like Larry. No, it's Dad.
Okay, all right. Add it to the comments below. Is Timmy's dad's name Dad, or is it Larry, or something of the sort? Okay. Decide whether the congruent statement is true. Explain your reasoning. Are these two triangles, DEF, congruent to DGF? Okay, they at least got the right order, corresponding parts. What else can I say here? So I would have had all the givens. What are you thinking? Yeah. Let's see. In this case, these aren't a rotation.
According to Google, he's never referred to by his real first name. It's either Timmy's dad, Mr. Turner, or simply Dad.
Okay. All right. Mystery solved. There are no more mysteries now that the internet exists. FD is congruent to itself by reflexive. And then I could say that the triangles are congruent how now? DGF by side, side, side. Right? Lovely. Lovely. Let me pick up the pace here. All right, I think I've got 2 of these proofs I was going to try, so we'll see. All right, G is the midpoint. All right, I'm going to hit all my givens. All right, givens, you know what they are. You know who you are, givens. G is the midpoint of EH. Okay, oh wow, that's a good thing I finished reading that. FG is congruent to GI, got it. And angle E and angle H are right angles. All right, so I'm going to say something to the effect of EG is congruent to GH. Anyone know why?
That's an angle of pi.
Def of MP. All right, I like it. I like it. Def of MP. So let's label that. Let's label that. I'm going to say that triangle. That's a sad triangle, but we can pretend EFG and triangle HIG are right triangles. I know that one feels like the hardest one to write. It's like, man, really? It's so obvious it's a right triangle. But why is it true? Def of right triangle. All right, there we go. Def of right triangle. I believe do we have enough information? I also, if I wasn't going for hypotenuse leg, which I think is what they want us to do, I do want to point out you also could hit some vertical angles. And maybe there's another way you could, I have side angle side in play. Today we'll talk about, I think it's today? Yeah, angle side. What? Who knew? No way. But they were just kind of rooting for hypotenuse leg today. We'll give it to them, friends. Comment? Question?
Angle F and I. What would that be?
If I knew parallelicity, but I don't just yet. But I could say these 2 triangles are congruent, EFG, HIG, because of hypotenuse leg theorem. Now that I know the triangles are congruent, then I could come in with a claim of like these are congruent, but the reason they would be is because of CPCTC. All right, it's because I already know the triangles are congruent that I could then make claims regarding all of the rest of their parts. All right, so that's kind of how you like fill. The CPCTC is just kind of like fill in the blanks. It's like you already hit like the home run out of the park, grand slam, and now you're just like running the bases like, guys, look at this. Did you know that first base is congruent to third base when it comes to the angle that is formed with the baselines? And you're just like running around like picking up all the slop. You know, that's what CPCTC does. That's what? Really? Let's see, one last proof. Wow, guys, this one's crazy sauce. Which triangles am I trying to prove, first of all? Because there's like multiple. VWX. Okay, so let me actually separate these twins and this one. All right, there we go. So I've got V dubs X. This one would be V again. No, this would be dubs V and Z. All right, there. What do I know? I know that WX is congruent. Oh, let's see. Let me throw Y, which is not necessarily the midpoint. Okay, like so. I know WX is congruent to VZ, WX, VZ. Okay, bop, 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 bop. I know that WY is congruent to WY. I guess I got to draw that here, huh? Is congruent to VY. And I know that YZ, nope. YZ, there we are, is congruent to YX. All right, lots of information going on here. I'm trying to prove these 2 triangles are congruent. We would start off with our givens. Man, I just can't write today, friends. Gimme. All right. And what else could I say? Thoughts? Sorry, what? But they are not in the triangle that I'm looking for. Yeah, these aren't the droids I'm looking for, friend.
WV is WV.
You're saying W what? Okay. WV is congruent to itself. That seems helpful. Reason? Man, we love that one. I don't know who my favorite property is anymore. Like, reflexive, def of Kong. I shows up a whole bunch these days. I don't know. I can't pick my favorite. So, yeah, this is a boo. Oh, that 1, 2, 3, 4. No, terrible. And all right. Do I have enough information now? Let's see. Oh, I know this is congruent and this is congruent. Actually, I have isoscelesness right there.
Yeah.
Wow. There's actually a bunch of weird ways I could do this. Guys, do you see this?
No.
Wow. That's so weird. I could find my third side by doing a segment addition postulate and show that this is congruent to that. I could use a base angles theorem and then show that this is congruent to that. Let's try base angles. I'm too excited about base angles, and I'm sick and tired of segment addition postulate. All right, I'm going to say that angle, I'll just call it XV dubs, is congruent to angle Z dub V. No? You guys, you aren't believing it? These angles are congruent because they are opposite of two congruent sides for this little isosceles triangle right there. So yeah, base angles theorem. BAT. Good old BAT. I actually told my wife's mother one time, because she's got a lot of nephews and nieces, that one of the nephews should have dressed up as Batman for Halloween, and then she could go up as herself and knock on the door first, and she would just stand there and go nana 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 nana, and then the nephew would jump out and say Batman, and it would every time would have been amazing, every time, because she's a nana. Come on, it would have been so great, and especially because it would have been 5 seconds of awkwardness before it made any sense. And even still, it might not make much sense. So let's see. So BAT, there we go. That was a divergent topic. Base angles theorem. And now in this sketch, I have that and that. Oh no, guys, it didn't help us. It's angle side to side. I still have to prove. All right, let's do this segment addition. All right, what do I know? I know that Vx is equal to Vy plus Yx by Segad Paust, right? All right, I know that Wz is equal to Wy plus Yz by the same token. I know that by def of Kong, I can prove this one and this one have equal lengths. Let's see. So I could say Wy is equal to Vy, and I'm just going to throw a comma in here. I also know that xy, or I said yx, I guess I'll use it in the same order. Yx is equal to Yz, def of Kong. Man, I can't believe I have to do this. Def of Kong. That's all right. So I kind of had this unnecessary but true statement in the middle. And by substitution, let's see. Does anyone spot the subs? So let's see, Wz is equal to Vy plus Yx by subs. Why does that help us? Does anyone know? Because check this out. This and this are the same. If this is equal to that, and that is equal to this, then these two must equal each other according to which property? Wait a minute. Sorry, okay, this arrow is pointing up there. All right. I was like, did I just say the thing is equal to itself? Because that would have not been helpful. All right, transitive, transprop. And now I can say that those are congruent. Oh, my goodness. By def of Cong, I'll do capital D. Mr. def of Cong to you. All right. And now that I know that, let's see, what did that help us with our drawing here? That showed that this entire side, right, is congruent, right there, is congruent to this entire side. All right, those are congruent. Blah. All right. Now, why does that help us? What do I have? I think I've got like side, 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 middle. Right? Yeah, we've got everything we need.
Wait, is there a way that if we prove that like the base angle here of one of the triangles, or not the base angle that the one of the triangles is the other one, the second triangle is congruent to the other?
Oh, like, so if I had this, and then we would have, yeah, we could have proved these two triangles were congruent.
That would have been logical.
And then, like, could I say that these two added together is the same as those two added together by some, like, triangle addition postulate?
Yeah.
That doesn't exist, but that's a really clever approach. I like it.
Like the area addition postulate?
Kind of, well, except, like, we're talking more than just area. We're saying, like, that it's actually resulting in the same shape, because lots of shapes can have the same area but aren't congruent to each other. All right, WVZ. All right, let's get out of this video. All right.
All right.
Bye, internet friends. Dinkelberg.